Okay, I'm going to demonstrate how we do the kickback method for factoring a quadratic trinomial. This first problem I have is 2x squared plus 11x plus 15. We use this method when we're trying to factor a trinomial where the leading coefficient is another number outside of 1. So our leading coefficient is 2. Right? The first thing we want to do is find out if there is a GCF other than 1. Alright, so in this particular problem, between the numbers 2, 11, and 15, there is no GCF other than 1. Alright, so we don't need to worry about that step. After you've searched for your GCF, the next thing you do is you take your A term and you multiply that to your C term. Alright? So, our next line would be x squared plus 11x plus 30. When we write this next line, we have to make sure that we lose the 2 out front and take that 2 and multiply that to the C term. Alright? So that's why we don't have a 2 out front. Now, after this, we need to decide how to factor this. And we do that by listing the factors of 30, our C term. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Alright? We need two numbers that we can add to get 11. So 5 and 6 are what we're going to use. Alright, so we're going to put our x's, we're going to put our 5 and our 6 in, and both of the signs should be positive. You look to your middle term, and whatever sign your middle term is, when you're adding, both of your binomials should have that. Alright, so it should be a positive 5 and a positive 6. Alright. Now, we can't forget about the 2 that we actually multiplied by earlier. Now we have to take that 2 and divide each of these numerical terms by that same 2. This fraction that you have now, if that fraction can be reduced or simplified, then you need to change it. Otherwise, whatever the denominator is, you take that denominator and you kick it back out in front of the variable. Alright? So 5 divided by 2 cannot be reduced or simplified to anything other than a decimal. So I'm going to take this 2 and kick it back out front. So now I'm going to change that to 2x plus 5. And 6 divided by 2 is 3, so this just becomes x plus 3. If the problem only asks you to factor, then you're done. These are the factors. However, if the problem asks you to solve, then you have to take this a step further. Remember when you solved this quadratic, if it had been an equation, when we solve it, we're looking for our x-intercepts. X-intercepts are also called zeros, solutions, roots. To do that, I'm going to take the 2x plus 5, alright, which is one of my factors. I'm going to set that equal to 0. I'm going to now use my algebra skills to complete this problem. So subtract 5 from both sides, and I have 2x equals negative 5. I'm going to divide both sides by 2, and I have x equals negative 5 halves, or as a decimal, that's negative 2.5. Alright? So this is one of your two solutions. Now, the next one that we're going to use is x plus 3. That was another factor that involved a variable. So we need to set it equal to 0, subtract 3 from both sides, and we have x equals -3. These two solutions represents our x-intercepts. Alright? This is where the graph will cross the x-axis. And our graph is a parabola. Alright? Alright, so let's go on to another example. Once again, the first thing we need to do is look for a GCF. Between 12, 17, and 6, there is no GCF other than 1. Alright? So we don't have to worry about that. The next thing we need to do is we need to multiply this A term, which is 12, to this C term, which is 6. When we do that, we change our A to a 1. So instead of having 12x squared, we have x squared plus 17x. 12 times 6 is 72. Alright, now we're ready to find the factors that we'll need. The factors of 72, I may miss some, but it's 1 in 72, 2 in 36, 3 in 24, 4 in 18, 6 and 12, and 8 and 9. So these are the factors of 72 that are our options. We're looking for two numbers that we can add to get 17. That's the 8 and the 9. So now we're going to set up our two binomials. We put an x here and an x here. We chose 8 and 9, so those are the numerical components of our binomials. Again, this is another addition problem, so both of our signs will either be positive or negative. And in this case, they're both going to be positive. We can't forget that we actually multiplied by this 12 earlier, that was our original A term. We need to now go back and divide each of these numerical parts by 12. Alright? Unlike the problem that I just did, 8 over 12 can be reduced, as well as 9 over 12. So we do need to reduce those fractions before moving forward. 8 over 12 is the same thing as 2 over 3, or 2 divided by 3. Also, 9 over 12 can be reduced to 3 over 4. Now that we've reduced each of these fractions, we're ready to kick back the denominator. So since 2 over 3 has a denominator and so does 3 over 4, both of these get kicked back in front of the variable. So to finally rewrite the problem, we have 3x plus 2 is one of our factors, and 4x plus 3 is the other. These two are your factors, and if that is all that you're asked to do, you're done. However, if your problem asks you to find the solutions, that means you need to find your x-intercepts. So you take each of these two factors, which both contain the variable x, and set those two factors equal to 0. Use your algebra skills and solve. So subtract 2 from both sides. You get 3 times x equals -2. Divide by 3 on both sides, and you get x equals -2 over 3. Which is the same thing as -0.6666, so on and so forth. So that is one of our solutions, or our x-intercept.